Hello, good morning students. This is Narendra Jain, Director Manthan Care Institute, Director Parshu International Senior Secondary School. Students, you can see my videos on my YouTube channel Narendra Jain Sir's Chemistry. Now, students, we are moving in the method of the preparation of the haloalkanes for the 12th class organic chemistry. In the last video, I have told you the method of preparation of haloalkane from haloalkane, that was the SWOT reaction, it was the last. Now, today we are moving for the preparation of the haloalkane from the alcohol. See students, there are the lots of method to prepare the haloalkane from the alcohol. First is the reaction with the HX. HX means reaction with the halogen acids. For example, halogen acids means HCl, HBr, HI, etc. So, when alcohol reacts with the HCl, then what will happen? H and OH, OH of the alcohol and H of the acid is removed and the haloalkane is obtained along with the liberation of the water. See students, in this reaction, we have got the two scientists named reactions. One is the Grove process and the second is the Lucas method. First is the Grove process, second one is the Lucas method. What is the Grove process? See, reaction is same. What you do, when alcohol is reacted with HCl, if I write it properly, we are going for the Grove process. Then what is the Grove process? When alcohol is reacted with HCl, and student, it should be in the gas phase. The trick is G means Grove and G means gas. If the alcohol is reacted with the HCl in the gaseous phase, then what will happen? The reaction is water will be removed and the product is CH3Cl plus water. The main thing is when it is going to be called as the Grove process, the condition provided is that what? If it is written Grove, it means HCl should be in the gaseous phase. Now, second is the most important, frequently asked question. Actually, this question is asked in the alcohol, but we will discuss here also. Lucas process. What is the Lucas process? When alcohol is reacted with the concentrated HCl. Here it was the HCl gas. Here it is concentrated HCl and ZnCl to anhydrous zinc chloride. When alcohol reacts with HCl and anhydrous zinc chloride, then what happens? Water is moved, CH3Cl plus water. This is the Lucas process, which is used for identification of the primary, secondary and tertiary alcohol. Means what? If in the three test tube, one contains primary alcohol, another contains secondary alcohol, another contains tertiary alcohol, then how can we recognize which test tube contains which alcohol? This is the method by the Lucas process. How? See, this is the Lucas reagent. What do you mean by the word Lucas reagent? Anhydrous zinc chloride and concentrated HCl is called as the Lucas reagent. Okay, anhydrous zinc chloride and concentrated HCl is called as Lucas reagent. See students, if we analyze this reaction that alcohol is reacting with the HCl, then it is clear that HCl will liberate H in the form of the positive ion. If H plus is there, then OH will go as negative ion. Then but obviously the intermediate is R positive. What do you mean by the word R positive? The intermediate is the carbonium ion. In this reaction, the intermediate is carbonium ion. Now see, we all have studied in the earlier videos that if we are focusing on the carbonium ion, then always remember tertiary is more than secondary is more than primary. Carbonium ion stability. And student, remember this point, whatever and whichever is the reaction, if there is the carbonium ion as intermediate, then order of the reactivity will always be tertiary is more than secondary is more than primary. Now see, when we mix alcohol and HCl, then the resultant is RCl, like CH3Cl, and it develops turbidity. Turbidity means milkiness in the solution. Solution becomes milky. Now see, if we have got the tertiary alcohol, we have got the secondary alcohol, we have the primary alcohol, then what I am writing on the board, see, that alcohol, since the order of reactivity is tertiary is more reactive than secondary and secondary is more reactive than primary, then tertiary alcohol will immediately give turbidity. And that test tube in which turbidity develops immediately, that is tertiary. I have written these three things. Immediately means I. And in this test tube, as soon as we add the Lucas reagent, turbidity develops, it means it is the tertiary alcohol. Now, secondary alcohol a little bit slower, it takes 5 minutes to give the precipitate at the room temperature. So, that test tube which gives the turbidity after 5 minutes contains secondary alcohol. And now see, what about the primary alcohol? At the room temperature, either it gives no turbidity or might possible it can give turbidity after 30 minutes, but generally in the NCERT book it has been written that primary alcohol does not give any turbidity. So that test tube which does not give any turbidity is containing the primary alcohol. So this is the way you can identify primary alcohol, secondary alcohol and the tertiary alcohol. Okay, now see. So we have discussed the two methods. One is the Grove process, second is the Lucas. Lucas is very important. It will be discussed in the alcohol chapter also. Now if we move ahead, Darzen's process. Again an important topic, straightforward question in the 12th examination as well as the IIT and the medical examination. Very easy and very important. When alcohol is reacted with SOCl2, what is SOCl2? Thionyl chloride. SOCl2 is the thionyl chloride. When alcohol is reacted with the SOCl2 in the presence of a compound named pyridine. What is the formula of the pyridine? C5H5N. Pyridine. Then what will happen? Chloroalkane is obtained. A very easy reaction. Then why we are focusing on this reaction very much? See what I am saying. When alcohol is reacted with a thionyl chloride SOCl2 in the presence of the pyridine, then chloroalkane is obtained. See this reaction. This is alcohol, this is SOCl2. What we do? One H and one Cl is liberated as HCl. O will go with the SO2, liberate as SO2 gas. CH3 and Cl is left. This is called as the chloromethane, HCl and SO2. See, in this reaction, sulfur dioxide is removed as gas. It is a gas. HCl is an acid. It will be absorbed by pyridine. What is pyridine? C5H5N is the pyridine and pyridine is a base. So HCl is absorbed by pyridine and SO2 is removed as gas. Then what is left out? CH3Cl is only left out. That's why this process is important, because by this process we can obtain pure chloroalkane. How pure? SO2 is removed as gas and HCl is absorbed by the pyridine. Now see. Next is by PCl5 and the PCl3. The fourth method. We have gone the three method. This is the fourth method by PCl5 and the PCl3. Very important. PCl3. Alcohol when reacts with the PCl3, it will form chloroalkane. But the main point to be remembered is three molecules of the chloroalkanes are formed. Alcohol when reacts with the PCl3, CH3OH, CH3OH, CH3OH reacts with the PCl3, S3PO3 is removed as phosphorus acid, CH3Cl, Cl and Cl, that is the three molecule of the chloroalkane is obtained. Next, by PCl5, see this student, when alcohol reacts with the PCl5, remember this point, then what I have written, only one molecule of the alkyl chloride is obtained. Here I have told you that three molecules. Here I am saying only one molecule of the RCl is obtained. Alcohol plus PCl5, what will happen? CH3 and Cl, one molecule is liberated. This H will go with one Cl, that is HCl, and one more product is called as the POCl3. Remember students, those compounds in which, those organic compound which has got oxygen like alcohol, phenols, aldehydes, ketone, carboxylic acid and its derivative, they always reacts with the PCl5 and one side product is always POCl3. Remember this point, one side product is always POCl3 and remaining products are there. Now the question arises, if the two test tubes are given, in one test tube we are reacting with the PCl3, in another test tube we are reacting with the PCl5, how can we identify where the PCl3 is there and where the PCl5 is there? See, that test tube in which white fumes comes, white fumes of HCl. In this reaction no HCl is there, but in this reaction HCl is there. This HCl will liberate as the white fumes, but obviously it is clear that test tube which gives white fume contains PCl5. That test tube from which no white fumes are coming contains PCl3. So these are the preparations of the chlorides. Now if we reacts with the for preparation of alkyl bromide, react the alcohol with HBr in the presence of concentrated H2SO4 dehydrating agent, water is removed, CH3Br is liberated. Now students, one new word I am giving to you, that is in situ. Question arises, what do you mean by the word in situ? In situ means any reactant which will be developed during a reaction in the test tube. In situ means a reactant which will develop or formed during a reaction in the test tube. See, alcohol I want to produce CH3I. Alcohol is reacted with either sodium iodide or potassium iodide in the presence of 85% phosphoric acid. Alcohol reacts with NaI or Ki in the presence of 85% phosphoric acid. Both these compounds will mutually react to form HI first. So this HI is produced in the test tube, that's why it is called as the in situ. Getting this point? And this HI will react with alcohol, water will be removed, I will come here, product is CH3I plus water is liberated. So that compound which is produced in the reaction is called as the in situ. Getting? Now, in this reaction, whole of the reaction, the intermediate is always carbonium ion. If the intermediate is carbonium ion, then order of reactivity of alcohol is tertiary is more than secondary and secondary is more than primary. Why? Because tertiary carbonium is maximum stable. Now the point is that what about the order of HX? Very clear concept. HI is more reactive than HBr and HBr is more reactive than SCl and SCl is more reactive than HF. Remember students, HF is least reactive. If we are focusing on the halogen, then fluorine is always more reactive. But I am saying it is halogen acids. In the halogen acids, HF is least reactive. Why? Because first reason, it forms intermolecular hydrogen bond. Remember students, hydrogen bond in general is formed by these three elements. Fluorine, oxygen and nitrogen. That's all. Except these, no other element in general conditions form the hydrogen bond. So HF, in HF, hydrogen is bonded with the hydrogen bond. That's why. And second thing, see, I'm drawing a diagram here. These are the two molecules bonded in this way, and these are the two molecules bonded in this way. Remember one more thing, students. More the difference in the size, easier is to be the bond broken. This bond will be broken easier as compared to this. So HI, this is H, this is I. HF, this is H and this is F. You can make it clear. In the HI, size difference is very much, therefore it will undergo the bond cleavage very easily. That's the reason why, two reasons, no hydrogen bond, here hydrogen bond is there, here size difference is there, it can undergo bond cleavage very easily. So these are the methods of the preparation of the haloalkane from alcohol. Getting this point? Next we will move for the carboxylic acid and so on in the next video.